Hi everyone, in today's lesson we're going to talk about different kinds of compounding. So today we're going to talk about compounding something continuously. So just like we did the other day, the formula is still the same. The A is still the ending amount, P is still the initial or principal amount. E this time is that number on the calculator, that constant number E. It's actually found if you hit the second divide button, you'll find that E button. So if you type it into the calculator and you hit enter, you'll get approximately 2.178. So it's kind of like pi, it's a constant number. R is your rate and T is the number of years. So what I'd like to do is a few examples about this and how it works. And since I don't have a calculator simulator, we could show you how to really use the calculator in class, but I want you to at least try. So we're talking about Nick investing $500 at a bank offering 7.5% interest, but this time the key word here is compounding continuously. So this key word continuous means the formula A equals PE to the RT, or PERT for short. So whenever you see this word continuous, you want to think compounding continuously formula. Okay? This is the best kind of compounding that you can get. So let's fill it out and see how much Nick will get after 5 years, rounded to the nearest dollar. So let's write the formula. A equals PE to the RT. So we want to find his ending amount, A, if he invests 500, which is his initial, E to the R, here's my rate, but again we don't put it in as a percent, we have to put it in, move it 2 places to the left, and put it in as a decimal, so 0.075. And T is 5 years, so times 5. Now I want to make sure that we put all of this in parentheses, okay, in the numerator, or not numerator, in the exponent. So I'd like you all to type this into the calculator just the way you see it, and see if you can get the same answer that I do. Now remember, the E is found by you hitting the second divide, okay? So take a minute, pause the video, type it into your calculator, and hit resume when you're finished. Okay, you should have gotten approximately $727 and 4.495, but it says to round to the nearest dollar, so approximately $727. That's how much money he would make after 5 years. Okay, let's try example number 2, where it says the population of Selden decreased continually, or continuous, by 2% each year. If the population is now 37,000, what will the population be 8 years from now if this trend continues? So we got the formula, A equals PE to the RT. So the initial population is 37,000, E, and now my rate of decrease is 2%. So how do I take that 2% and turn it into a decimal? Well, I move the decimal 2 places to the left, so it's 0.02. And now 8 years should be times 8. Again, this whole needs to be in parentheses. And what I'd like you to do is type this into the calculator again, just the way you see it, and then hit resume when you're ready to see the answer. Okay, so if you type this into the calculator, you should have gotten something around 43,419.90. But we're talking about the population of Selden decreasing continuously. But what happened here? We went from 37,000 to 43,000 approximately. So this looks like the trend increased instead of decreasing. So there's something wrong with our formula here. And I did this on purpose because I wanted you to see what would have happened if you didn't make, here it is, the rate negative. So this is not correct. You must have a negative rate. So what I'd like you to do is retype this into the calculator now just the way you see it with that negative inside the parentheses instead. And then hit resume when you're ready for the answer. Okay, you should have gotten, with the negative, 31,529.32. So approximately 31,529 would be the population. Now that makes much more sense because it started at 37 and it decreased to about 31,000. Okay, so word of advice, if it's decreasing, you must have a negative rate. So decreasing means rate must be negative. Okay, so we're going to skip 3 and 4, and we'll do those another time. But let's move on to the next page. Okay, so I want to talk about something called a half-life, okay? So if you're in chemistry, you've learned this before, but this is the formula for half-life. And the best way that I can explain it is through a sports example. Say we had 8 teams beginning in the playoffs, and after each round, half of the teams are eliminated. So after round 1, how many teams are left? You should be telling me 4. After round 2, how many teams are left? You should be telling me 2. And after round 3, we should have our winner. There will be 1 team left. Okay, so this is a half-life problem where this is the original amount and this is how many times it's decreasing, but by 50%. It's half the teams. So if I wanted to write down this formula, the formula would be exactly what you see here. A equals P, 1 minus 50%, the teams are going down by 0.5, to the T. So anytime we're talking about a half-life, it's when things are decreasing by 50%. And we can simplify 1 minus 0.5 to just 0.5. So this, A equals P, 0.5 to the T power is the same exact thing as this, and this is the formula that we'll use for half-life. 0.5 to the T is the same thing as 1/2 to the T. Okay, but it's very important that we know how many rounds we're going or number of half-lives. So let's look at example number 1. It says the half-life of carbon-14 is known to be 5,720 years. Dr. Frankenstein has 300 grams of carbon-14 in his experimental lavatory. If untouched, how many of the 300 grams will remain after 1,200 years? Well, the first thing that I notice is that this 1,200 years here has not quite hit 1 full half-life, because we'd have to be at 5,720 years for this thing to totally half at all. So if we're at 5,720 years, then we will have 150 grams left, because that's half of 300. So we know it can't be 150. Our number is going to be greater than 150, because this 1,200 is not 1 full half-life. So we actually have to write the half-life as a fraction. 1,200 out of 5,720 is the part of the half-life that happened. So when we put this into the formula, A equals P times 0.5 to the T, this T has to be written as a fraction if it's not a full half-life. So it would have to be written as years, whatever years we have, over the half-life that's given. So let's see. The way it would work would be A equals 300, that's my principal, 0.5 to the 1,200 over 5,720. And that's it. You put this into the calculator just the way you see it, and you get an answer. So pause the video until you've done so, and then hit resume when you're ready. And you should get approximately 259.398. So approximately he'll have about 259 grams left, right? Definitely not 150. Okay, now let's look at part B. If untouched to the nearest tenth, how many of the 300 grams will remain after 10,000 years? Well, 10,000 years is definitely more than 1 half-life, because 1 half-life is 5,720 years. So if we divide them, we'll be able to figure out how many half-lives. So it's approximately 1.7. If you put it in your calculators, it's approximately 1.7 half-lives. So again, when we put it into the formula, it's going to be A equals, we're starting with 300, 0.5 to the 10,000 over 5,720. You don't want to put the decimal, you want to put the exact, so we're going to put the fraction. So again, type that into the calculator just the way you see it, and then hit resume when you're ready for the answer. Okay, Now, what do you think the answer is going to be? Is it going to be less than 150? Well, let's see. If we start with 300 and we have it, we're at 150. And if we have it again, we're at 75. So from here to here, this is one half-life, and from here to here is another half-life. So we're not yet at two half-lives, so this has got to be between 150 and 75. So if you hit enter, your answer should be about 89.29, which rounds to about 89.3. And we were definitely right. It's between 75 and 150, between one half-life and two. Okay, so I know that's a new concept, half-life. So we're gonna be finished for now. And if you have any questions, jot it down. But the rest of this we'll go over in class tomorrow. Okay, have a good night.